Okay, so I'm the mad scientist, and I'm here and I want to show you how to make a do-it-yourself ambi-light system for your HDTV. If you're not sure what this thing's pretty cool. Basically, we're going to put LEDs around the back of our television, and from there we can control these with a mini computer, which we call a Raspberry Pi. If you're not familiar with it, it's a really awesome device. Okay, so let's get started. So first we need a bunch of different materials. Raspberry Pi 2 will work just fine. 3 is recommended. 3, the difference is with the 3, it's the same cost as the 2. It's a newer device. It has Wi-Fi and Bluetooth built in, and it has a faster processor. If you can't get your hands on a 3 though, and you have a 2 available to you, that's fine. That'll work. Definitely need an 8 gigabyte or larger Class 10 SD card. The image that I'm providing here from my SD card was put on an 8 gigabyte card, so anything smaller and it's not going to fit. But 8 gigabyte or bigger is fine. You don't need to have a bigger one. 8 gig will do the job. Let's see, the 2.5 amp USB to micro USB charger. This is how you power the Raspberry Pi. The Pi 3 recommends that you have 2.5 amps because that's how much power it's going to send to your USB ports. Alright, next we need an Arduino Uno. Those are cheap. You can. I provided links to everything, but they generally cost around $5, so that's no big deal. HDMI splitter, an HDMI selector, HDMI to A to V converter. Okay, we want to make sure when you buy it, it's capable of upscaling to 1080p, and then a USB grabber. Okay, it's important for this tutorial, I'm not saying the other ones won't work, that you find one with a chipset. It's a Fushai chipset. I think that's how you say it. Anyway, it'll say UTV007. And I also provided a link to that. Also, we need a 5 volt 10 amp power supply to power the LEDs. That should be enough of a power supply to probably power 10 meters of these LEDs. For my setup, I think I used like 3.5 meters for a 42-inch TV. But it depends on how many LEDs per meter you get. My setup has 30 LEDs per meter, but they have better ones now where you can get 60, even 140 LEDs per meter, which would be really awesome. Any of those will work fine, but just remember the number of LEDs determines how much power it's going to take. And HDMI cables. Obviously you're going to need a few of those. You'll need the WS2812B RGB strip. 5 meters should do most TVs. And some wire and a soldering iron and some double-sided tape. This is how you secure these to the television. Let's move on. Now here's a materials links list. Hold on just a second. I'll go through each of these links right now, but anyway, I did provide links here to each of the devices that I bought that work great. I found them cheap on AliExpress. If you're not familiar with that site, they have a lot of things that are pretty cheap. The only problem is they come from China, so they may take a couple weeks before you get them. Okay, so anyway, go ahead and look at these links, buy these parts, or find ones that are the same, maybe cheaper somewhere else, and this is what you're going to need to make this system work. Now I've also provided a few software links. The reason I did this was I've been trying to build this system for a while, and most of the tutorials I found online are severely out of date. They're not made to work with all HDMI devices. They're made to work off of one device only, which most of us have several devices, or you don't watch everything from your computer. If you do watch everything strictly from your computer, then you don't need the Raspberry Pi, you don't need the splitter, you don't need those things. There's a cheaper way to do this, but I'm not going to cover that in this tutorial. Basically, all the information I found out there was either outdated or came from some Russian website where, you know, things are tough to follow. So I wanted to make this easy for everybody. So in this first link I provided here, this is actually contains the Arduino sketch you're going to have to load onto the Arduino Uno. It also contains the disk image that the Raspberry Pi is going to need and the Hypercon.jar file. This file is what you'll use to configure your setup once you're done. Then there's a link to the Arduino IDE. In case you don't already have it, you'll need it to load sketches onto the Arduino Uno. The NeoPixel library for the LED strip, that is part of the Arduino IDE. I'll cover how to install that as well. And then the Win32 disk imager, that is to actually burn the image to the SD card that I provided in the other link. Okay, so the first step for all this is to configure the LEDs on the back of the TV. This isn't that difficult to do, and this is where you'll need your double-sided tape, unless the RGB strip that you bought already has a 3M adhesive on the back. Many of them do. Mine didn't, so I just used double-sided tape. So you always want to start at the bottom left corner to place that row of LEDs, and you're going to make sure that the arrow on the strip of the LEDs is going to the right, and then you're going to cut the strip when you get to the corner, and make sure you cut it like I show in this arrow right down the middle of those solder pads. Okay, now you're going to place a strip on the right side, and be careful to make sure that the arrows are also going in the same direction. We want this to be one continuous strip of LEDs once it goes around the TV. So now we do the same thing to the top, and we are going to arrange them so that it's going to the other direction. And then lastly, on the left side, we are going to do the same. As you can see, this makes a continuous strip around there, starting at the left bottom corner. So you're facing the back of the TV and you're going counterclockwise. Once we turn the TV around to the front, the LEDs are going to go clockwise. Okay, so now the next step. Once you've attached them all to the TV, you need to solder the corners together for the LED strips to make this a continuous strip again. This drawing here shows basically how to do it. You have to make sure that you're not mixing these. Ground has to go to ground, 5 volts to 5 volts, and D out goes to D in on the next strip. Don't mix the pads, it won't work. Okay, now you want to do this for all 3 corners that we had to cut, but don't worry about the last corner. We don't need to do it for that. That's actually the end of the LED strip. So once it's all soldered back together, we now have a continuous strip. I'm pretty good with a soldering iron myself. I do this for a living. However, they do make, and you might be able to find these on AliExpress, corner junctions for these that just snap into place, and so you won't have to solder. I didn't use those. I don't know if I trust them personally, but you can look around and see if you can find those. That'll make it go a little faster if you're not very comfortable with a soldering iron. Alright, next you want to wire this LED strip up to a power supply that we bought, the 5 volt 10 amp power supply. In the case for this, you'll want to make sure that you go from red to V plus or plus V in this case, and black goes to V minus, which is your, for DC, your plus and your ground. The third wire, sometimes on my RGB strip it was green, sometimes they're blue, but that's going to connect to the Arduino later. If you haven't done so already, you also need to wire the power supply to a wire plug to go to the wall so you can plug it in. I found an old computer PC power cord and just cut the end off, and inside I had these colored wires. I looked online, I found out what color wires go to what, and most of them are the same, but double check your particular wire for the color codings that you'll need to go to this power supply. Okay, next. Oh, also it's a good idea to have a ground from the power supply going to the Arduino. This is important. You might get flickering on the LED strips, random colors. If you don't do that, the Arduino is actually supplying the data to the RGB strip, and if it doesn't have the same ground potential as the RGB strip does, then you might get data errors. So it's just a good idea to run the extra ground from here to the Arduino. The Arduino has several ground pins. Just pick any one of them and it should work fine. Okay, now we need to count the LEDs. We're going to have to use this information later for the Hyperion setup. So before you turn it around, count them. We need to know this. So first we want to count the number of vertical LEDs up and down. My particular TV, I had 16 on the left side, 16 on the right side. So then you want to count the horizontal LEDs. Mine has 28. Yours, like I said, mine was 30 LEDs per meter. If you're going with 60 LEDs per meter, or if you have a larger TV or a smaller TV, your count's not going to be the same. So just make sure you count these, you write them down, and then you also need to know the total number of LEDs all the way around. And basically it's just going to be 2 times the vertical sides, 2 times the horizontal sides. Once you know that, write them down. We're going to need this information for both the sketch, for the Arduino, and for the Hyperion app later. Okay, so at this point, as far as the hardware setup goes, the hardest part is finished. So now we need to move on to the software part. And there's really 2 parts to this, or 3 I guess. The first part is going to be to install the Arduino IDE on your computer and then load the sketch. Now, once again, here's the link to the Arduino IDE software. You'll need this to load up the sketch and then transfer it over to the Arduino. Let's see, so basically just take the Arduino and plug it into any of your USB ports and then open the sketch that I provided in the software package link. Okay, and I think I called the sketch Ambilight Hyperion. You're going to change, if you look at the sketch, you can see here mine has 88, but this is going to be the total number that's on the system you're building. And also you can see here this data pin 10. That's the data pin. That's where the data is going to come out of your Arduino to go to the RGB strip. So don't change that number. When you plug your Arduino into your RGB strip, you're going to be plugging it into data pin 10. And also, look at the baud rate says 500,000. Don't change that either, but you'll need to know that later. That's going to be this. You need to put that same number into the Hyperion sketch. Okay. Now, one other thing is to make this sketch compile and load correctly, we need that install the right library on here for the NeoPixel master. So let's see, I thought I provided this. Yes, I do. Okay. So you're going to have to install this library to the Arduino IDE. And you also want to make sure under the tools menu board to select the Uno and to select the correct COM port that you're on. And that COM port may change depending on if you unplug it, plug it into a different USB port. Sometimes it'll change your COM port. Just check it and make sure. So I told you the download link before for this NeoPixel master zip file. I just download them and put them onto my desktop so they're easy to find. And then in here you're going to go to Sketch, Include Library, Add Zip File, find that file, hit OK. It's going to install it automatically and you should be all set. Next you want to go to the Sketch menu and hit the upload button, which is right here. That's going to load the sketch to your Arduino, and now your Arduino is all programmed. You're done. You don't have to do anything else. Alright, now next we're going to install the pre-configured Pi image I provided onto the SD card. Basically, you're going to have a zip file or a RAR file, and you need to extract the file OSMC pulse setup all working that was included in the software link. That's the card image. Now, what this is a copy of OSMC with Kodi 16.1 Jarvis on it. If you're not familiar with Kodi, you're going to love this software. This is like a Netflix on steroids. Anything you can think of, any movie, any show, you'll find it on there, and it'll stream it live just like a Netflix system would. And then I also put a custom build on it called Pulse. What it does is that adds a lot of different add-ons into it that make it really nice and smooth and easy to find the content you're looking for, whether it's a movie, whether it's music, whether it's TV shows. It's all there. And I mean, this basically turns your Raspberry Pi into a full-on multimedia system. And you'll notice that it has the Aries wizard on it as well. What that is it's basically a wizard that will let you try different custom builds that are already pre-configured for you on there. If you're a sports nut, you can find a custom build for sports. If you just like movies, if you like a kids build that has nothing but kids shows and stuff, you're going to find it all on there. So basically, once you've got it on there, you can go ahead and mess around with the Aries build, and you're going to love it. It's great. And it's fully up to date, not like some of the other tutorials where everything's 2 years behind. This is current as of today. And I've already loaded all the drivers that you're going to need for everything on here, which took me days to do using the old out-of-date tutorials that I could find. Basically, this is why this setup's going to be much easier for anybody to build. Everything's up to date and everything works. So it's already got a basic, my version of Hyperion's on it, set up for my TV, but I'll be showing you later in this tutorial how to make a few changes to get it all set up for yours. It'll be very easy. Once you've burned it to the, or once you've unzipped it, then you got to put your SD card in the PC, and we're going to double click on the WinDisk32 Imager program that you downloaded already. That's going to be where you install it, and basically all you need to do is run it as administrator, select the image file, and select the SD card in your computer, and then write. And once it's done writing to the SD card, you're all set. Just put the card in your Raspberry Pi, and that part of it's done. Okay, moving on. Now we get the fun part. We're going to hook it all up. Okay, so it looks kind of like a lot, but it's not too bad. And in the end, it's a little messy, but you can easily take this and put it into a nice custom fixture of your own, any kind of box, and it'll work nicely and it'll look nice. But you got to make sure whatever you put this in has some kind of ventilation. I put it all into a box and it was running fine, but it would reboot occasionally. I found out some of these devices make a lot of heat, and it was actually rebooting the Pi occasionally. Once I put some ventilation in, which was just a few slots in the box so air could flow, everything's working perfect. Okay, so first thing is, your power supply is plugged into your RGB strip. Now plug the data line into pin 10 of the Arduino. If your wire doesn't have a plug that can fit into the plug, it's okay to just solder to pin 10 underneath the Arduino. That works fine too. In fact, soldering may even be a better idea because it gives you a better connection. And then plug the Arduino via USB cable into the Pi. And that's it. The Arduino is powered by the Pi's USB, so we don't need to do anything else there. Okay. Now select plug an HDMI cable from one of the outputs of the HDMI splitter into your TV, and then plug the output of the HDMI selector into the input of the HDMI splitter. Now on your splitter, plug the second output of that into the HDMI to AV converter. And also at this time, you can plug all your HDMI devices into your selector. Now, on the HDMI to AV converter, we don't need the audio at all. We're only going to process the video. So you can see on the output side of the HDMI to AV, the yellow output is your video line, and we need to connect that to the yellow input on the video grabber, on the USB grabber. So just plug in that. Don't worry about the audio cables. We're not going to use them. Okay, now the USB grabber needs to get plugged into one of the USB ports on the Pi. One thing I found is that the grabber needs a little bit more power than most of the other USB devices. So on the Pi, you have 2 stacks of USB ports. Plug the USB grabber into one of the 2 stacks that's not being used by anything else, so that it's the only device on that stack. That's going to give it enough power to run properly, and it won't be splitting the power into more than one device. So right now you should have the USB grabber in one stack and the UNO plugged into the other stack. And if you're going to plug in a USB keyboard or USB mouse or a USB remote, I would plug it into the same stack that the UNO is on and leave the grabber on one by itself. Okay, so everything's hooked up. Now we're going to power it up and configure Wi-Fi in the OSMC. So power it up, turn it on. On the TV you should see your OSMC come up, and this way when you can get into Kodi, it'd be nice to have a keyboard or mouse because you really need to control it somehow. So once Kodi is fully booted up, navigate to Programs and select it. Okay, now look for the selection called My OSMC under your programs. That's going to open up your OSMC setup menu, and this is where you're going to go to configure your devices. But mainly right now we need to configure your network settings. So at the very bottom you've got the network icon. Select that. Now select your wireless on the left, and if you plan to use Wi-Fi. Otherwise, if you're just going to use a network cable, you don't need to worry about Wi-Fi. The Pi 2 doesn't have Wi-Fi. So you should see a list on the right screen of all your wireless networks. So select the network you want to join, put your network password in and connect. I found sometimes it takes a couple times to get a successful connection. Sometimes it says it's unsuccessful, but you reboot and everything comes up fine. Just go back in and go back to your settings, because now you want to write down the IP address that you're going to get once you're connected. And you're going to need this later with the Hyperion, the Hypercon, to connect to it and upload your new Hypercon configuration file. Okay. So that's really it. Now your Kodi setup should all be done, and you can begin streaming all kinds of video content through Kodi. You can select a different HDMI input, whether it's a cable box, an Xbox, a Roku, you name it, Amazon Fire Stick. You're gonna love this setup. But so as far as the hardware goes, we're done. The last thing to do is modify the Hypercon file for your particular setup. So we're going to configure Hyperion. So run the Hypercon file that I included with the download folder, the big zip file. Once you run it, you're going to see it. It's going to look just like this file here. Double click in, open it up. Okay, so now we're just going to modify a few settings to make it, for your setup. So basically, in the hardware tab of the Hypercon, you want to make it look like this. It's got to be an AWESOME for type. Your output is going to be the dev TTY USB-O. Then we're going to change your baud rate to 500,000. Remember, that's what was in the Arduino sketch, so this needs to match it. Otherwise, it's not going to work correctly. Okay. And now over here for clockwise. Now these settings here, these have to match what's on your TV. So remember I told you to write down your horizontal and vertical LED numbers. You're going to change these values here so that they match. Okay, and then once you do that, if you look at the GUI, this first LED offset, for me it was 44. Just modify it until 0 ends up down in the bottom right corner of your TV. You'll be able to see it change as you modify it. Okay, and some I didn't in my setup, but if you have an LED in the corner of your setup, you can select these check boxes. Okay, leave the rest of the settings for now. You don't need to mess with them. You can change those later if you want to change the depth on these two settings or the overlap. You can. I usually wait till later after everything's working and then just play around with those. Okay, yeah, and now click Save here. So you're going to save all these files to a DAT file. I usually save it to my desktop. You can save it wherever you want. Okay, now on the Process tab, pretty much there's no need to change anything in this tab yet. You can adjust later if you want to. For me, I got it all working first and then went back and changed my saturation, my gain, and my gamma a little bit, just to fine tune it. It's going to be different for every setup, so the default settings are usually going to be just fine. So again, click Save. Every time I make changes, I save it so I can go back and mess around with it later. Okay, now we're going to go to the Grabber tab. Okay, so pretty much just make it look the same as it does in this picture here. Okay, I uncheck the internal frame grabber and check the grabber here. Make sure the device is the same and all these settings are the same. Then click Save again. Okay, now the external tab, you pretty much just make it look the same as it is in this picture again and click Save. Now this is a good place to also create your configuration. So the very bottom button here, Create Hypercon Configuration. Create that, save it to a location of your choice. I usually will save it to my desktop. It's an easy place to find it. Okay, now the last tab, this is the SSH tab. This is where we're going to upload the configuration to your Raspberry Pi. So for this to work, your computer needs to be on the same network as the Raspberry Pi. So basically, for target IP, your IP address that we recorded before from your OSMC settings on the Pi. So write that down from before, just put it in here. Leave the port at 22, and for username and password, we're going to use OSMC and also OSMC. Once you've done with that, save it. Now click Connect. You should be connected to your Raspberry Pi. So from here, we're going to click the Send Config button. That's this button here that's grayed out in this picture. I'm going to click that, and that's going to update the Raspberry Pi with your configuration, not the one I already had loaded on it. So all these changes are going to get uploaded, and we're going to click Save. So now we're going to create the configuration one more time, because that's going to save these other changes that you just made. And later when you go back into it to fine tune it, you won't have to go through all this again. They're already in it. Alright, so once the Raspberry Pi has a new configuration on it, reboot the Raspberry Pi and it should work. It takes about 20 seconds before your LED strips will light up and start working. That's because there's a delay in the Arduino code that's there on purpose to let the Raspberry Pi finish booting up into OSMC before it starts transmitting the data to your LEDs. So that's normal. Okay, so at this point everything's done. If you've done everything right, your new system should be working. And nothing left to do but some fine-tuning. So I've also added a couple extra thoughts here. So like I said before, if you get some occasional flickering, double check that your connections from the LED strip to the Arduino are not loose, because that can result in some random flickers of color. If you do want to box it all up and make it look nice, which I did, remember that these components, especially the Pi, will get pretty warm, so give it some ventilation. If you don't, you're going to get some random rebooting. And then go to the Hyperion wiki if you want to do any color calibration or fine-tuning. And that's about it. So it's going to be a little different for every setup, but actually the default settings, the basic settings, work pretty well. So you won't really need to do much fine-tuning here. Okay. This should do it. At this point, everything should be working perfect. And if you have any problems, just go over and double-check everything. Also, another thing that can give you some random flickering is if you have something plugged into the same circuit that's very noisy, like a vacuum cleaner or things like that, can cause that. But other than that, it should work pretty well. So just give me some questions in YouTube if you have any problems, and I'll respond and try and help you out. Okay, this is the Mad Scientist signing off. Look for some more future videos from other tech stuff that I like to put together.